Hey everyone! In this video, we're going to continue looking at L'Hopital's rule, and we're going to take a look at an example where we actually have to use L'Hopital's rule more than once. So just to start off with, remember what the rule says. If we have a function where, as we're trying to find the limit, if we end up with an indeterminate form of 0 over 0 or infinity over infinity, we can use the derivatives to help us evaluate. So what we do is we find the limit as x approaches some number c. We use the derivatives of the numerator and the denominator. And if we can find the limit of that, so that's equal to some number L, then that's the same as our original limit. So then the limit as x approaches c of our original expression, this is also going to be equal to L. So that's what L'Hopital's rule says. So now let's take a look at my example. And what we're going to see is we actually have to use L'Hopital's rule more than once. So the first thing, just to verify that we do have an indeterminate form, if I try to evaluate this limit just by plugging in 0 for x, I would end up with the sine of 0 minus 0 all over 0 squared. In the numerator, the sine of 0 is equal to 0. So we get 0 minus 0 is 0. And then in the denominator, 0 squared is also 0. So we do have this indeterminate form. So that means we were going to want to use L'Hopital's rule. So the first thing, we're going to find the derivative of the numerator and of the denominator. So the derivative of sine of x minus x. So the derivative of sine is cosine. Then the derivative of negative x, that's going to be minus 1. And then the derivative of the denominator, the derivative of x squared is 2x. So rewriting then, this limit is going to be equal to the limit as x approaches 0. Our new numerator is the cosine of x minus 1 over 2 times x. But now, if I take a look at my new expression, if I try to evaluate this limit, I'm actually going to end up with an indeterminate form again. So the cosine of 0 minus 1, and then in the denominator, 2 times 0. The cosine of 0 is equal to 1. So 1 minus 1, we end up with 0. And then in the denominator, we also have 0. So this is still an indeterminate form. So what that means is we have to keep going, and we're going to use L'Hopital's rule again. So we'll take the derivative of the numerator and the denominator one more time, and hopefully now we'll end up with something that can be evaluated. So the derivative of cosine of x minus 1. So the derivative of cosine is negative sine. The derivative of negative 1 is just 0. And the derivative of our denominator, the derivative of 2x, we just end up with 2. So now our new limit, the limit as x approaches 0 of negative sine of x over 2. And now we have something that is not an indeterminate form, and we can actually evaluate this. So if we plug in 0, we have the negative sine of 0 all over 2. As we discussed earlier, the sine of 0 is equal to 0. And 0 divided by 2, so our limit is just equal to 0. If this limit is equal to 0, our middle step here, that limit is also equal to 0, which means that our original limit as x approaches 0, this function is approaching 0 as well. So L'Hopital's rule, sometimes it is necessary to use it more than once, but we can keep going. We can get it down to a point where we don't have an indeterminate form anymore, and then we can evaluate the limit, and then that's the same as our original limit before using L'Hopital's rule.